This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today.
Hi, everyone, and welcome to Slooh's latest live show. This is quite a historic day, and we're so happy that you've joined us to watch as the New Horizons is going to make its closest approach to Pluto. This is a mission that's been years in the making. We've seen this craft as it's left Earth, and it's gone far, far out into our solar system, passing by even the planet Jupiter as it makes its gravitational assist goes even further out into the solar system. This is a mission that started in 2006. Jupiter, as we're seeing right here, came by in 2007. And then after that, New Horizons was very quiet for quite a few years. It was passing by Jupiter, and then it didn't quite see another really big object for quite a while. We went to 2008, 2009, 2010, and now we're all the way here at 2015, when New Horizons has very recently come out of hibernation as it's coming to meet with the dwarf planet Pluto, which we're going to be counting down to on our show here today, as this craft gets very, very close to a part of our solar system that we have not been able to explore very closely until now. And so this is the second part of our three-part show series on the New Horizons mission, with the first part happening just yesterday, where we talked about a bit of a retrospective about what are these images that have been coming out of this New Horizons mission. What have we been seeing as features emerge on Pluto? And today, this is the second of three shows where we're going to be counting down. This is actually going to be happening in just about 18 minutes. We're going to be experiencing this close approach, and we're so happy that you've been able to join us for this. And of course, we're going to have a show tomorrow when, while the close approach was happening, we're now going to be seeing images coming out on Wednesday, July 15th. We're going to be having a show at 5:30 Eastern, 21:30 UTC, and we're going to be seeing what those images look like as we're seeing the closest approach, 7,800 miles away. What can New Horizons provide us? Then after that, of course, on Sunday, we're going to be getting a little bit closer by. We're going to be seeing the close approach of the $5 trillion asteroid. So that's all coming up on Slooh. But for now, yes, the countdown of the close approach. I am joined here today by Slooh astronomer Bob Berman as we're going to be talking about the history of Pluto leading up to this exciting, exciting day. Thank you so much for joining me today, Bob.
A whole lifetime for this. This is great.
It really, really is. I mean, there's been so much that has happened with Pluto in really the last century, and I mean, where can we really start in terms of talking about this planet? Like we were looking at it yesterday through the live Slooh telescopes from the Canary Islands, where we're just seeing this dot on the screen among a field of stars that really, to the naked eye, really didn't seem much different from anything else out there in terms of the pinpricks of light, but it is so significant. Like, how were we able to discern that?
Well, true. No human being has ever seen Pluto directly as anything but a pinpoint of light. I mean, it started, since we're doing a brief history of it, it started with the search for Planet X after Uranus was discovered in 1781. And okay, then came Neptune in 1846, and the two planets seemed to be moving in an odd way as if they were tugged at by something else. No one expected Uranus. Neptune was predicted mathematically, so why not another one? And so there was a hunt for it, led by such people as Percival Lowell. And it was at the Lowell Observatory in 1930 that an assistant, Clyde Tombaugh, who wasn't even a certified astronomer. In fact, he would say so. He'd say, I'm not a real astronomer. I'm not like these other guys. And yet his name will live in history because it was he who took a photograph in the constellation Gemini. There he is. In January of 1930, the photograph was looked at using a blink microscope, sometimes called a blink comparator. And what that does is examines two star fields, one after another, blink, 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 back and forth, back and forth. And if any star in that field has shifted position, it's going to seem to jump. There it is. Jump back and forth, back and forth. And there it is. And that's the Discovery photograph. That bright star above it is Delta Geminorum, the fourth brightest star in the constellation Gemini. It just so happened that Pluto at that time was at its most northerly or most favorable place to be seen for people in Europe, the United States, Canada, in its entire 248-year orbit. So there was the Discovery and its changing position. And it was they waited until March 13th of 1930. How do I remember the date? Because that's the anniversary of the discovery of Uranus, the very first planet back in 1781. So they decided to wait till then to announce it, and the whole world went crazy about it. First new planet discovered since 1846. So therefore, we had one discovered in the 17th century, another planet in the 1700s, 1800s, and now 1900s. This was the discovery. Unfortunately, as time went on, we saw that this couldn't be the massive planet yanking at the other two. It was way too small. And we didn't realize how small it was, but it's really such a small planet that it finally got demoted back 9 years ago for a variety of reasons that we can talk about. But it wasn't until a year later that the Walt Disney Company decided to really add fame to it by calling their only non-speaking character. They only had one cartoon character that never said a word, and that was a dog, cartoon dog named Rover in an earlier cartoon. Well, Walt Disney decided Rover, let's change the name and exploit this new planet that everyone's talking about. So they called it Pluto in honor of the planet. It wasn't the other way around. The planet wasn't named after the dog. Of course, as we all know, it's now been demoted. Pluto has to a dwarf like all the other Disney characters. You know, now it's not a major planet anymore. And if you like, we can talk about that. The reasons for doing that. I noticed in the New York Times there, some are still not happy about that, but they probably did the right thing if you, when you really look at it. But in any case, that's the brief history, and nobody's really seen it. Oh, Eric, we had opportunities back when the Voyagers blasted off in 1977. The planets were aligned just right for a visit to all of the planets, including Pluto, which was still a planet back then. But Congress kind of bewilderingly said, all right, you can go to Jupiter and Saturn and Uranus and Neptune, but no Pluto. We're not going to fund Pluto. And then there was another opportunity about 20 years ago, and that was canceled. But now we finally did it. Now there's finally the mission that arrives during this show in a matter of minutes from now. Finally, a
It
close approach. And what a
it's
close
really
approach. We're going to be passing so close, it's going to be one Earth diameter away. I mean, Earth is 7,926 miles in diameter, and the New Horizons craft will be flying 7,800 miles above the surface. So we're talking about just almost precisely one Earth diameter. So picture what you could see if you had a high res camera flying, skimming just above Earth. So we're going to see lots of detail. I think something like 25 meters per pixel. So um, very exciting.
it absolutely is. Yeah, because we see that when it was first discovered, it was just this dot moving across the screen, and now we're just seeing this dwarf planet flush in features and variations that we could have had no possible conception of when we were looking at it and just simply wondering, imagining. And so now we're just 12 minutes away from the time when we're actually going to be experiencing this close approach. It's going to be so incredible. We're so happy that you've decided to spend this close approach celebrating with us. And as we're getting so close there, Bob, I'm wondering, do you have anything in particular that you um, most want to see out of this close approach? You most want to learn or in somehow see that is on Pluto in any way?
Well, of course, you know, even the Pluto is a tiny thing. I mean, let's remember that the satellites of Jupiter, the two largest ones, which are Ganymede and Callisto, are 3,200 miles in diameter, and so is Saturn's major moon, Titan. These are 3,000-mile in diameter moons. This one is 1,473. Now we've pinned down the diameter finally. 1,473 miles in diameter. So less than half the size of some other moons. So when we're talking about, okay, it's not a planet anymore, it's a dwarf planet, don't feel too bad about it because it's only half the size of a number of satellites of other planets. It's a small body, but we feel closer about it because it was a planet, because it's the largest, now we know it's the largest object out there past Neptune, and because we've been curious about it for so long. It's gone from a dot, as you just said, Eric, to more and more detail as we've approached. This is the fastest ever spacecraft that we've ever blasted away. For example, the Voyager spacecrafts, which were not slow at all, when they took off in 1977, it took them until August of 1989. That's 12 years to reach Pluto's distance. At that time, that's when they reached Neptune, if I remember correctly, on August 24th or 25th, 1989. And at that time, Pluto and Neptune were exactly the same distance from the sun. So to go this far from Earth and the sun took that craft 12 years. This one's made it in 9, and it just shows how speedy it was. Blasted off on an Atlas V rocket, the fastest of the Atlas V rockets, the fastest ever spacecraft we've sent from Earth. So this one's not coming back. The spacecraft's going to whiz past and just keep going out into interstellar space thanks to its 24 pounds of plutonium. It's got plenty of power, I believe about 200 watts of power to send back images. And those images, that's what we're talking about now. As, of course, it gets closer and closer, we see more and more detail. First, we see blotchy things and we give names to them. Oh, there's the whale. There's a heart. And but as you get closer, you get more refined. Sometimes you get something that looks like something that we can relate to. You know, we humans love to see things, ink blots, Rorschach tests, just like some people saw a face on Mars in the Cydonia region. Later, years later, when we took a higher resolution picture of the same spot, there was no trace of a face. We could see it was just rocks with shadows cast by those rocks, and it was nothing resembling a face. So look at this. This was from about a week ago, and there's a heart on the lower right. So, in fact, we're all calling it a heart, all the planetary geologists, because that white area, and it really looks like a perfect Valentine. And when a picture was taken just yesterday, or at least it came in yesterday, now we get better resolution. So it's still heart shaped, but the bottom of the heart now is kind of moving off the screen. And if we could see it from down below, it might look like something else. The right side of the heart isn't really good. We'll probably still call it a heart. The stuff on the left looks like it's breaking off, like the Gulf of California, like Catalina Island, and some of the other shapes. So, you know, you start out with some crude um, words and generalizations about an area, and then as you get closer and closer, it gets really exciting as you can see detail.
It really, I mean, there's just such a big difference from one week to the other. It's absolutely incredible, and it will be really, really intriguing. We're just 6 minutes away from the time of the close approach to see how all these features sort of work together and what they mean in terms of planetary and I suppose dwarf planetary formation and how uh, all of this came to be. We were actually talking, just the other day about Charon, one of Pluto's moons, and about how there looked like there was an intriguing impact crater that could have been there. That it was very reminiscent of how some of the craters might look on the moon. And what does that mean in
Yeah.
terms of our solar system's formation? How all this stuff came to be where it was, and what what sort of relationships these objects may have? How can we have this really similar feature on this moon far, far away, and then our moon very close by? And what does all that mean? It'll be very
Well,
intriguing to see what comes out.
yes, it is. Fortunately, this is one of the easier ones to answer. You can see on the lower right, there's obviously an impact feature because you can even see white rays streaming away from it in all directions. So that really is the telltale fingerprint of an impact feature. We see this on the moon and surrounding Copernicus and the crater Tycho, where you see the crater and you see the lines of material, ejecta, that's being thrown out in all directions. On the moon, it goes for thousands of miles. This is only about two-thirds the size of the moon. Actually, Pluto is, Charon is half the size of Pluto. And even though it's spelled Charon, still it should be pronounced Charon. These are all creatures from mythology. And the major moon, the only round moon on Pluto, we've known about this for years. And they're locked in a sync, tidal sync. Pluto and Charon go around each other every 6.4 days. And unlike the story with Earth and our moon, where our moon keeps one hemisphere always facing us, but we don't. We rotate under the moon, and that's why you can see the moon rising and setting. That's not the case on Pluto. On Pluto, one half of Pluto has Charon in the sky, always, and the other half of Pluto is Charonless and never sees Charon in the sky. So the two of them are locked in sync, and because they're so similar in size, Pluto and Charon only have a 2-to-1 diameter ratio. It means that they're going around an empty spot in space. So here's the first case where you don't even have a moon really circling the planet. Our moon comes close. Our moon orbits a spot that's 1,000 miles under Earth's surface. In other words, the moon's not orbiting the center of Earth. The moon is going around a spot only 1,000 miles below the surface of Earth. So once every 27.3216 days, the moon goes around this spot right under Earth's surface, And once every 27 and a third days, the Earth makes a wobble around this spot under its own surface in the direction that it faces the moon. So they both go around this barycenter, this center of gravity that's still within Earth, contained within Earth's surface. Not here. Look at this Pluto and Charon picture. The two are so close together and are so of equal mass, not exactly equal, but equal enough that the two actually orbit around an empty spot in space between them. So when we used to talk about Charon being a moon of the planet Pluto, it's really more true that they're a double object. They're a double dwarf planet, perhaps that's the best way to put it.
And seeing, there's just so much variety in our solar system. It's absolutely incredible to see. And just, we're coming down so close to the close approach. And just to keep you excited, we actually have an interview with Dr. John Spencer, part of the New Horizons science team that Will talked with John Spencer just a couple days back. And right after the close approach, we're actually going to show you part of that interview to sort of let you know what the science team itself is excited about as this close approach is getting very, very close. And as we're getting close to this close approach, I just have to wonder to myself, we have things that we do when we see, a shooting star, we can make a wish, but what is it, we should do to celebrate experiencing a close approach? Is that a wish? Should we dance an Irish jig? What are your thoughts on that, Bob?
Well, here we are, less than 2 minutes from the first, and probably in our lifetimes, the only close approach to Pluto. Imagine that, less than one Earth diameter away from Pluto, coming up in a minute and a half. We could do our best Pluto the dog imitation. Remember Mickey Mouse going, "Hello, Pluto." We could say, "Hello, Pluto." We could think Plutonian thoughts. Pluto is named for the god of the underworld. Because this is dark, forever orbiting in the Stygian depths of the solar system. That's why even its moons, its features have names from classical underworld features. The boatmen who rode through the rivers of hell. But no, let's not go there. That would be too depressing. Let's instead just think our own Pluto thoughts. All our lives we've been aware of Pluto, and now for the first time we visit it 40 seconds from now.
And here we are. We're showing sort of the trajectory. We're going to arrive at Pluto here. I think that was a great sentiment, Bob, to say hello, Pluto, as we pass by. I think I might do that. And you were seeing again that it went right by Jupiter and then went way past the orbits of the planets we know. Just 20 seconds, and it'll be there.
Okay, then let's all do that. All Slooh members. I wish we could send this to NASA. We'll all go our best Mickey Mouse imitation, saying
Oh
hello to
no!
Pluto as we pass it in 7, 6, 5,
Five,
4.
4, 3, 2, 1. Hello, Pluto.
Hello, Pluto. And there it is. Our close
uh,
approach. I mean, and going fast. This is 8 miles per second. That's 16 times faster than a high velocity rifle bullet. So this is a fast close approach. This is not like an orbiting mission, the way the Cassini mission orbited and still is orbiting Saturn, or the Galileo spacecraft orbited and still is orbiting Jupiter. And we have a number of Mars orbiters still up there. This is just flyby, because that's the only way to do it. It's the only way to get there this fast. So there's no way for the New Horizons to slow down, to orbit, to have a leisurely look. All the cameras are clicking now. We can't get any images. It's too busy. It's too busy taking pictures. It won't be until later today that we get back a word from the spacecraft. Yeah, I'm still okay. That's going to happen about 4:30 Eastern time. We're talking 8 hours from now, that the craft will finally take a moment out from its busy pre-programmed schedule to communicate back with mission control and say, "I'm still alive. I didn't run into a pebble out there that was unseen in space that destroyed me. I'm still alive." And then tomorrow will be the time when it finally sends back, and we're going to do a show on that, sends back its first images, close-up images that'll be so exciting, although it's going to be a stream of data and images that won't fully arrive back on Earth until late next year. That's how much stuff it's going to have. Because it's one thing to gather the data, it's another thing to send it back with only a 200-watt spacecraft over that 4.5-hour distance that it takes light to travel from Pluto to Earth. So this is almost a slow motion data retrieval. Do you prefer data or data?
Oh, I'm too American. I'm data.
Okay.
I'm sure Will Gator, our friend over in the UK, would be data. No, I can't speak for him though. But we've just experienced this close approach, and you're right. We're going to see these images so soon. It's just going to be the following day. We're going to have another show on Pluto and the New Horizons. It's going to be the third show in our three-part series. We hope you'll join us for that as well as we talk at 5:30 Eastern, 21:30 UTC, 2:30 p.m. Pacific, to talk about what the newest New Horizons images are, the close approach images, the ones where we've been seeing this geometry coming into view, all these intricate features, the heart, the whale, the chasms, the craters. What will we see with these close approach images? And then, of course, on Sunday, join us for the $5 trillion asteroid. We talk about the close approach of this very, very expensive asteroid and what the future of asteroid mining may have for the different organizations on Earth. But for now, we actually have a really fantastic interview that Will Gator did with Dr. John Spencer of the New Horizons mission. And so, as we've experienced this close approach, let's get a little deeper into the science team's perspective on it. There's a lot to learn, and they're excited to learn it. So, check this video out.
In terms of the features that we see in these images and what you expect in the flyby, what sort of geological formations might we see in the coming days?
Well, that's really the $700 million question. We really don't know if a world the size of Pluto that is not in orbit around a larger body that might produce tidal heating, like some of the moons of the giant planets, whether it is capable of generating enough heat in its interior to support active geology, ice volcanoes, or faults, or things like that. And so that's a really key question about worlds this size, and it's one that I think Pluto will help us answer over the next few days. So we might see a surface that looks something like Neptune's moon Triton, which has a very exotic surface that we don't begin to understand, of smooth plains and faults and blobby regions and things we call cantaloupe terrain, because they look more like the surface of a cantaloupe than anything we've seen anywhere else. But that's a very young surface with very few craters. And we don't know whether Triton has produced all this activity because of its intrinsic ability to produce heat in its interior from radioactivity, which Pluto can do as well, or whether it's because it's in orbit around Neptune and is being heated by Neptune in some way. And so if Pluto looks like Triton, then we know that just radioactivity is sufficient to power these exotic kind of formations. And if Pluto looks like a much older, heavily cratered surface, then we will be, it'll be strongly point to Triton requiring tidal heating from Neptune in order to have that kind of exotic surface. So that's really a basic question that we want to answer. We know quite a lot about Pluto in terms of its atmosphere and its moons and its orbit and its surface composition, though there's enormous amounts more to learn from New Horizons. But we know absolutely nothing right now from the geology other than what we are wildly guessing from these still quite low resolution approach images.
And I guess the images are only part of the picture, really, aren't they? Because we've got this lovely picture of New Horizons on screen at the moment. What other instruments are going to allow you to make those scientific observations and really find out what's going on down there?
Oh, yes, absolutely. We have a high-resolution black and white camera that is what we're mostly using right now. We have a color camera, which also can map the amount of methane on the surface and where the methane is distributed, because it's sensitive to wavelengths of light that are absorbed by methane. But we also have an infrared spectrometer that takes images in 256 different wavelengths of infrared light, which is very diagnostic of what the surface frosts might be. We know there's a lot of absorptions in the spectrum due to methane and nitrogen and carbon monoxide and probably other things as well. And this instrument, the LISA instrument, will allow us to map the distribution of those features across the surface in amazing detail, and will tell us a huge amount about what the surface is made of and the processes that are moving frosts around on the surface. Then we have an ultraviolet instrument that will be probing the atmosphere, particularly as we go behind Pluto and pass through Pluto's shadow. And we will see the sunlight being absorbed by the atmosphere and being received by the spacecraft and picking up the signature of whatever's in the atmosphere. So we will be very interested in the results from that experiment from the ultraviolet instrument. And then we have plasma instruments that are actually going to be tasting directly the molecules that have been escaping from Pluto, and will tell us directly what the atmosphere is made of, maybe how fast that atmosphere is leaking out into space. And that's really unexplored territory because we've never been to a place like Pluto before, which has an atmosphere that escapes in the way that we think Pluto's atmosphere does. So that's going to be very interesting to get those data back.
Long story short, we really have a lot to learn as we're flying by Pluto, and the science team is on it. We're going to have so much that is going to be coming out of this mission. And of course, if you found this interview very intriguing, we actually have more of the interview, and we're going to be showing part of that tomorrow as well during our third part live Slooh show, where we're going to be showing the close approach images as they debut for us on Earth. And of course, we're so excited to be doing that as well because just last year we signed a Space Act agreement with NASA, sort of celebrating amateur astronomers and protecting the Earth from any near Earth asteroids that are coming by. And it's great to be celebrating that partnership by showing some of that imagery to you throughout these shows this week. And as we are getting sort of near the end of our official celebration of the close approach of New Horizons to Pluto, it's happened and you've experienced it, and we are taking just one more step in terms of exploring our solar system. Do you have any sort of final thoughts, Bob, on what this whole extravaganza means to you or to us on Earth as astronomers, as viewers of space?
Well, you're using the word final, Eric, and in one way it's very appropriate because this is the final uncharted planet that we're now visiting. Throughout our lives, we grew up, many of us, with 9 planets. This is the last of them. There's almost no chance that there's going to be new planets unless the IAU reverses itself, decides that Pluto is a planet, in which case there's going to be other planets that have to be planets as well, in which case new planets can be announced, in which case we might send a spacecraft someday to visit those new, but they're going to be little dwarf things. Pluto seems to be the largest of the dwarf planets out there, the Kuiper Belt object. So in one way, this is the end. This is the final. We finally visited Saturn and Uranus and in 86 and Neptune in 89. And finally, here it is, 2015. And we finally visited Pluto, the last of them. So the word final is appropriate. On the other hand, the images are still to come, in our next show. Now we dig in with this feast. Now we look at what the close-ups will show, which are going to be nothing like this. The image we're showing right now, look on the screen here. We're showing you yesterday's picture. Wow, that's gorgeous, gorgeous detail. But if you compare it to a picture taken just one day earlier, let alone 1 week earlier, as New Horizons was approaching, the detail is geometrically increased. So what will we see from that close-up that happened during this show? Live while we were here today, what is that going to look like? So not quite the word final yet, because I'm looking forward to our next Slooh show when we start to sample and look at what's coming in, when we really get close-up views of Pluto, and the New Horizons craft has time to stop its acquisition phase and start sending us the pictures, which it can't do yet. That's for later.
So right, the excitement from New Horizons is just beginning. And so, as we're going into our next show, of course, keep in mind, we're going to be answering questions for this one in our great celebration of this whole event on Twitter, we're going to be keeping an eye on the hashtag Slooh New Horizons. So if you have questions for us, use that hashtag, or else you can always talk with us in the clubhouse on the live shows page. We love to hear your questions there as well. So yeah, do stick around. We're so much having fun this week as we go through this exciting event with you. So yeah, thank you again for taking the time to experience this with Slooh. We're so happy to be able to bring in this incredible event with you. And so yeah, we're going to be coming on the air again tomorrow. Again, 5:30 Eastern, 2:30 Pacific, to celebrate the first images coming in from New Horizons. And so as we fly by Pluto, there's just going to be so much more to learn. So do stick around with us. But for now, this has been Eric and Bob for Slooh.